Chapter 8, Section 3, this is the example 2, and which was part of Section 1 again. But let's step through this. We're getting a little more complex on how we're creating our equations. It would be good to review some of this stuff. And then apply probably a different strategy on how we're going to solve systems again from Section 2. Well, this is a total value problem, that we're going to go through first. The next example is a mixture problem. I'll probably break that into a separate video. Well, let's go through this jewelry design. In fact, like I said in the other prior video, this is this first chapter I've ever seen where they probably jump right into a complex word problem, though they didn't expect us to solve that. This was one of them too. They said they really wanted to show off the fact that we can take a more complex kind of word problem, and with applying systems we can make multiple equations and we can find answers to these things using this new strategy, really, of applying what we know about linear equations to multiple linear equations and find solutions for the system, which is a solution for all the equations involved, which we're really just dealing with two now. So this example was introduced in Section 1, and let's go through that again. It says, in order to make a necklace, Starbright Jewelry Design purchased 80 beads for a total of $39, excluding tax. Some of the beads were sterling silver beads costing 40 cents each, and the rest were gemstone beads costing 65 cents. So how many of each type were bought? And we went through that familiarize and translate steps. If you want to go through that again, it goes a little more detail in section 1 of this chapter 8.1. But we end up generating these two equations, and which again, just a little review. Usually this easier equation to generate is the one that's easy to miss. Is that they said they bought a total of 80 beads, and then when you define your variables in that process that they used in section 1, and that's what I do is I'll define the variables, reread the actual word problem, and fill in the variable for the word that I'm substituting it for. So like S is the sterling silver bead, so I would reread that and say, hey, I got these total beads, some are sterling silver S, and some are gemstone G. So I have these S and G things that need to add up to 80. There's your equation. The other one is a little more complicated to do. There's a table that was generated that says, well, if I got the cost of the silver beads, it would be 40 cents times the silver beads, and the cost of the gemstone beads was 65 cents times the number of beads, gemstone beads. And then they convert it and say, hey, rather than have cents and dollars being talked about, let's all use cents. So we got 3,900 cents to represent $39. There's my two equations. So we decide which strategy are we going to use. Are we going to use substitution or elimination to solve this system? And usually when things are in standard form, which means that the variables are on one side of the equal sign, usually you can use the elimination method, which is the addition principle applied in a special way for these two equations. So, and that's what they do. They manipulate the first equation, equation 1, S plus G equals 80, and they say, if we took negative 40 times both sides of that thing, I would create a situation where I have an additive inverse for this 40s that's in the other equation, equation 2. And that's the goal. Again, remember, when you use an elimination method, I want to create a situation where I can add these things together and eliminate one of the variables, because if I have an equation with one variable, I can solve that and get a number. And then I go back with that number through substitution, and I can find out what the other number for the other variable needs to be equal to, right? So just kind of summarized section 1 and 2, really. So they do that. We end up with this equivalent equation. Again, equivalent means that all the solutions to s plus g equals 80 will be the same as negative 40s plus a negative 40g equals negative 3200. That's negative 40 times both sides. Remember, you got to distribute that multiplication. So now when I add this to this side of this thing, right, and this to this side, I'm really using the addition principle, and I add those together. Hey, negative 40s plus 40s equals 0s or 0. They don't even fill it in. You end up with 25g equals 700. So g equals 28. Okay? Well, now that I have a value for g, that's one part of my solution to this system, is I know how many gemstone beads there are. Well, to find out the other one, I just substitute that into, and probably the easier equation would be that addition that equal 80. And I put 28 in for g, so what does s have to be? Well, it'd have to be 52. So what we obtain, and I like that they bring it up as an ordered pair again, because it really relates back to chapter 3 stuff. I have an ordered pair. I have an a g value and a s value. Why did they put g in front of s? Well, it goes alphabetical order, unless they tell you otherwise, right? So there's an ordered pair. And then I need to say, well, what does that mean? That I got gemstones, or 28 gemstones and 52 silver beads. The only reason really to do this line here is to say, remember we worked with ordered pairs. Again, if you think about section 1, we did it graphically. Hey, this ordered pair is where these two lines of these original equations intersect. That means that there are the only common point or common ordered pair for those deals. It relates to that because it's good. It is not a good way to solve these systems isn't by graphing, because we don't necessarily pull out exact values, especially if we have fractional x and y, or in this case g and s values. So, but it's still good to have a visualization of what's going on, because that's exactly what a picture of this would look like. Hey, we have two lines that are not parallel in this case because they intersect. They intersect at this one ordered pair. That ordered pair gives me information that I need to answer this word problem with. So the whole process of translating to linear equations and then solving the system is there's a picture of that hopefully in your mind. So what does this mean? It says that for these conditions to work for both of these conditions, or these equations in a sense that we generated from what they're telling us is going on, we end up with 28 gemstone and 52 silver, sterling silver ones. Okay? Well, then we check that. Or also we check and say, does this make sense? Well, does 28 plus 52 equal 80? Yeah, we should. That's one of them. But also I should check the other equation. Does it fit that? Does 65 cents times 28, where do they get that? Well, that's the cost of the gemstone beads. And I think I have 28 of them. So what's the cost for just gemstone beads? It'd be 1,820 cents, right? And then what's the cost of the silvers? I got 40 cents for each one of those, so I'd multiply that times 52, and I'd end up with $20.80, right? Or 2,080 cents. Does that add up to what my money should be? 3,900 cents is $39. Hey, these numbers check, so I can answer this question. And what is the question? They want to know how many gemstone beads were used and how many sterling silver beads were used. Well, that's exactly what those variables are defined to be, which is a good way to define your variables. Is you look at the question and say, what are they looking for? What are the things that I need to pull out of all this computation strategy and working with systems so I answer the correct question? And that would be number of gemstone beads and number of sterling silver beads, right? And I'll stop there and we'll make another video for the next example.